Hello and welcome. In this class, we'll create a bridge in RouterOS and we'll add some devices, and those devices will be in the same broadcast domain. And we'll see how that device is going to behave and how we'll allow the communication based on the MAC address. I'm going to use GNS3, so we can simply add a device here to the work area. This is going to be a router, a Mikrotik device, but we'll create a bridge interface on it. And also we'll need some virtual PCs, so we can add 3 of them. And now we can simply connect those PCs to that Mikrotik device. So this is going to be on Ether 1, then we're going to have that connected to Ether 2, and the third one is going to be on Ether 3. So we have 3 devices. And now to have access via Winbox to that device, I will add a cloud. This is going to allow the communication with my local network. So I will connect the cloud to Ether 8, for example. Now we can start all those devices, and after a few seconds, that device should be visible in my local area network. So now the CHR is visible, so we can click on the Mac, admin, the default username, no password, and then the first step is that we need to create a bridge interface. So you can see the steps here. Step number 1, create a bridge interface. There is going to be a logical interface that can have multiple ports as slaves or members. So let's go here to the Winbox, and to create a bridge, we are going to click on the main menu here under here on bridge, and then we'll create a new bridge. So if I add a new bridge, I can simply give it a name. Let's say bridge LAN, for example, and then we can simply click OK. So now we have a bridge, but this is an empty structure at this time. It's just a logical bridge, but we haven't mapped physical interfaces to it. If we check our topology, we can see that we have Ether 1, we have Ether 2, and Ether 3. So all those interfaces will be in the same broadcast domain. By default, that device is going to have a different broadcast domain in every interface. If we need to have the same network in all those devices, we need to put those devices in that bridge that we have just created. So let's go back to the bridge. Here, still in the bridge menu, you can see that the second tab is ports. So basically here is where we can add ports to a bridge. If I click on new or add, basically here we have 2 fields. We're going to pick interfaces, and we're going to put those into a bridge. So we are going to add Ether 1, we are going to add Ether 2, and also we are going to add Ether 3. And basically now we have created that bridge inside our operating system. So now the interface 1, 2, 3 belong to that bridge that we call bridge-LAN. So now that's the interface where we can set an IP address, and basically those 3 physical interfaces are simply members of that bridge. And all the devices that are connected to those interfaces will be in the same network. So this is how we can create a bridge in RouterOS. So now we can assign IP addresses, and that IP address is going to be directly on the bridge interface. So once we have added those interfaces to the bridge, we're no longer going to set IPs in those interfaces because they are slaves in that bridge. So bridge is now the visible structure from the layer 3 perspective, and it's going to allow layer 2 communication between all the members, all the ports that belong to that bridge. So let's say that I'm going to use, for example, the network 192.168.1.0/24, and I'm going to add the IP.1 in the bridge, and then this PC is going to be .2, this is going to be .3, and .4. So let's go to the router, and we are going to add that IP to that bridge interface. So I will come here, IP addresses, and we'll add a new IP. 192.168.01/24. That is going to be on the interface bridge LAN. Now we can click OK. So you can see I'm adding the IP on the bridge interface, not on the physical interfaces. Next step, so we're using 10, so I will change that. Instead of 01, we want to see 11. Okay. So now in those PCs, we are going to set an IP. We can use DHCP or we can use static IPs. We already know how to configure DHCP, so we are going to use DHCP. Also, I will add a DNS server here to this device because that is also going to be suggested when creating the DHCP server. So now we are going to IP DHCP server. I'm going to use the wizard that is going to be running on the bridge. So you can see here as well, we are going to put the DHCP server on the bridge interface, not on the physical interfaces. So bridge LAN, this is taking the network address. This is going to be the gateway, the IP that we set on the bridge. This is the range of IPs that find, DNS server, list time, and that's it. So now we have a DHCP server running on the bridge interfaces. And all the devices connected to ports that are members of that bridge will be able to get a dynamic IP. So let's see here. Let's go to PC1 and I will open the console for the device. And I'm going to do the same for PC2 and also I'm going to do the same for PC3. So now we have console access to all those devices. So if I go here to PC1, I will say IP DHCP, enter. This is going to go through the DORA process, and now we're going to get an IP. You can see 1.254. If I go to PC3 here, IP DHCP, this is also going to get an IP. And if I go here to PC2, IP DHCP, they are getting an IP, and all those IPs belong to the same network. 1.254, 1.253, 1.252. They are exactly in the same network because we have a bridge. So let's see what is happening here from the perspective of RouterOS. So now if I go to IP, DHCP server, leases, you can see that we have all those IPs that have been allocated to those devices, server DHCP1. And you can see here that RouterOS knows what is the bridge port that has been used. So you can see 1, 2, 3. So RouterOS knows exactly where that device is connected. And if we go to bridge and then to hosts, so here we can see the MAC address, the interface, and the edge. So basically that's the MAC address table. You can see that we have dynamic. So that means that that entry was added dynamically into that table. If now we have one of those devices sending a packet or frame to any other device in the same network, the bridge is going to come here, it's going to check where that MAC is connected, and it's going to send a frame out of that interface. So you can see that under host. You can simply go to a terminal and say interface, bridge, then host, and then print. And this is going to show you the same output that you have in the table in the Windows. So basically those MAC addresses are connected to those interfaces. You can see the age, that's basically how long that entry has been there in that MAC address table. And now if I go to those devices and I try to ping a device in the same network, those devices have connectivity. So basically the operating system in that PC realized that the destination is in the same network, and then is simply going through the R process that we covered in the previous section, then is sending the frame to the switch, and the switch is forwarding the frame based on the destination MAC and using the host table that you see there. The host table is equivalent to the MAC address table. And also you can see the ARP entries that basically will have the same information. But in this case, this is also mapping the IP address. So ARP is happening as well if the router is going to send packets to those IPs. But in our previous case, ARP was performed in that PC before sending the frame to the switch. And this is how we can allow the communication inside the same network by using bridge interfaces. If we want to provide access to internet to those devices, we can have a different network, and the network must be in a different broadcast domain. So in my case, if I check the connection of the router to my cloud that is using Ethernet 8, my router has a DHCP server, so I can create a DHCP client in that Ether 8 interface, and now this is going to have an IP from my local network as well. So let's do that just to provide access to internet to those devices. I go to the DHCP client and will remove the default client on Ether 1, and I will add a new one on Ether 8. And I will say OK. This is going to look for a DHCP server out of Ether 8. It found my home router. Now we have an IP coming from my local network. And if I check IP and then routes, you can see that we have a default route that has been injected via DHCP. We have the connected network going to my home using Ether 8. And also we have the bridge network 192.168.10/24. But at this point, if I try to ping an IP on internet, that is not going to work. And that is because we need NAT. So NAT is also going to be required here because we need to masquerade those packets when leaving that router. So same thing that we have done in the previous classes. We need to go to IP, then firewall NAT. We need a source NAT entry. Traffic that is going out of Ether 8, going to my home's network, is going to use the action masquerade. And now if I go back to POTI, you can see that we have access to internet. So you can see clearly that the IP that we have on the bridge is used to route traffic to remote networks. If we are going to the same network, we only need the MAC address. And the host table is going to provide that information. We can clearly test that. For example, if I come here and I disable the IP on the bridge, and if I try to ping a device on the same network, this is still going to work. Because in this case, the IP on the bridge is not required because the destination is in the same network. That PC knows that, and is simply going to send a frame directly to the MAC. But that is going to be sent to the switch or bridge, and the bridge is going to check the host table and will forward that to the destination device. So basically, this is how we're going to be allowing the communication in layer 2 with devices in the same network and using the IP on the bridge to reach remote networks. So this is pretty interesting how this implementation has gone here in this Mikrotik RouterOS device. And finally, every time that we are creating a bridge, that bridge, as we saw previously, is going to need an IP to reach remote networks, and obviously it's also going to require a MAC address. By default, the MAC address will come from one of the MAC addresses of the member ports. That means that if we reboot the device, probably that MAC address is going to change. If we want to set a fixed MAC address, and also this is a good practice, we are going to use admin MAC, and we are going to disable this automatic process that is enabled by default. So let's see how this is going to work. So if I go now to the main tab bridge and I open that bridge, you can see that the MAC address now is 870000. If I come to the interfaces, that's the MAC address that we have on Ether 1. If I see Ether 2, this is 01, Ether 3, 02. So basically, that bridge took the MAC address for Ether 1 and put that into the bridge LAN. If we want to set a static MAC, we can simply use this admin MAC address option that we have here. For example, let's copy that value. And now instead of 0, 0, let's say that I'm going to use 10, 0, 10, 0. And I apply the changes. So now you can see that the new MAC address in that bridge is 87.10.10. And that value is always going to be the same independently of the interfaces that are members of it. So this is a good practice, just to keep the same MAC address all the time. This is how we're going to work with bridges on RouterOS. In our next class, we're going to explore when that bridge is going to work, using a chip that is in a device or using software. That's basically an optimization that we can perform just to take advantage of those hardware capabilities. Thank you, and I see you in our next class.